Hey YouTube, I wanted to show some detail on my automatic spent primer removal thing I built here. I guess I'll begin with the strategery, if you'll pardon the Bushism of what I'm trying to do. I reload in fairly high quantities, and my goal is sort of to have reliable, safe, accurate ammunition kind of with the low cost and low time per round kind of deal, trying to be both time and financially efficient. And I've found I really like to decap prior to wet pin tumbling. Mainly that allows the most of the grit to be removed from the primer pocket. Doesn't affect reliability so much, but it keeps all the carbon and grit from getting into your progressive reloader, and kind of the cleaner and better lubricated you can keep that, the smoother it runs and the faster things go. So I wanted a way to quickly decap large amounts of brass, and something that was fairly inexpensive, because I'd be running, unclean brass with grit from the range, whatnot, through it. So this Lee APP, is quite inexpensive. I'm sure if you are watching this video, you're familiar with what it is, but basically it's a single stage press that can feed cases from a tube, and uses a, unhook the airline here so I can manipulate this. That went flying. It uses a tube to feed cartridges that drop down into that little shuttle, and then it uses a express, they call it, shell holder that's open on both sides, and a little set of plastic jaws there leaves the case over the shell holder, and the next one comes and knocks it loose. So things I've changed, obviously. I've adapted it to a Dillon case feeder. That's pretty easy to do. I just kind of measured, the case feeder sits on a piece of square 1-inch tube, and the cases drop into the feed assembly here. And I've just mounted this Lee on a plate with a piece of 1.5-inch pipe welded so that the distance to where the cases drop into the Lee is similar. And then this has kind of a funky angle, how that square tube goes up into the case feeder there. So, but I also, if you can't engineer something correctly, or your craftsmanship isn't that great, you make it adjustable. So that's why I used a round tube, and then I 3D printed out of some TPU just a square sleeve with an 1.5-inch outer diameter with a little ridge on the end of it to keep it from falling in, the square 1-inch inner diameter. Then I drilled a hole through the back of the pipe and welded on a 1/4-20 nut, and I didn't have any 1/4-20 wing bolts, so I just jammed a regular bolt through a wing nut, and that's my support for this. Then the Dillon case drop tube is larger diameter than what the Lee takes, so I just printed a little adapter and cut off a piece of the thick tube for the Lee case feeder. And then stock, it would come with this little tube holder that would take different size tubes for different cartridges. And then along here on the back are a couple jam nuts and a bolt that you'd use to adjust the height of that tube holder to fit whatever cartridge you're using. Well, a fella from Germany designed this piece to be 3D printed, and it uses the large tube for all calibers and has a caliber specific little snap-in piece. This one's for 9mm. It has kind of a funnel shape, so it can use that large tube and not hang up. And the advantage is, if I wanted to switch to, say, 45 Colt, I could just pop out this 9mm piece and snap that in. And the end of the drop funnel is, the length is correct for the right case pusher that snaps on top of this shuttle. And the upper opening there, the cutout for the case, is designed to, so the case sits on this slide here, and that opening will allow the case to slide out. So that works really well. Problems I've had with it, it will sometimes bobble, or as I got using it, it would bobble quite a bit, shoving a case into that express shell holder. And what would happen then, the case would be misaligned, it wouldn't be properly centered, and you could easily have the primer pin, the decapping pin there, miss the flash hole in the case and possibly break a pin. And I found actually, this is that shuttle piece. And if this will focus that close, you can see it's worn a massive slope on it. That's supposed to be the same thickness right on across. And that was allowing this slide to tip under this spring pressure and was causing it to malfunction. So Lee will send you replacement parts if you just pay for shipping. So that's what I did. And this thing has had a lot of rounds run through it that are not clean, that are gritty, so I can't fault Lee at all. That's exactly what I wanted, was a cheap decapping thing that if I wore something out, it was no big deal. And that's precisely what Lee has delivered with this. So that's kind of the case feeder and the Lee press. I was hoping to get, Lee makes a decapping kit specifically for this. I actually got one, but I had to send it back because part of it was broken in shipping. But it has kind of a set of fingers that drop into the, you actually remove not only the shell or the die, but the die holder there too, and you drop that piece in and another little piece. And long story short, it uses these fingers to kind of center an imperfectly dropped case, and it also doesn't use this express shell holder. You get a little flat plate with a hole for the primers to drop out instead. And I think that will be the way to do it, because this will still occasionally drop a case not quite well aligned, and then you'll see it'll hit the decapping pin pretty hard. And then if you do get a primer suck back too, it's not locked in there by the rails. It can just tip out into the bin. And then it'll get called, you know, after I pin tumble these, they get an inspection before they get washed. So I can always, you know, decap it or throw it back in with spent brass. So let's go on to the pneumatic setup here. Kind of, this thing's sort of a pain to set up with a linear actuator because this arm pivots on that pivot, and that pivot bobs up and down based on, you know, this linkage and that linkage. But I was able to kind of do a little measuring and a little math and figured a 250 millimeter stroke would be sufficient. And again, I made this adjustable because I didn't want to beat this press to death. So this is just a piece of 1/4-inch plate with an M12 bolt, because that's what I had laying around, and I just plasma cut a radius on it here, another M12 bolt, you know, M12 eyelet, like an M12 by 125 or one, kind of an odd thread pitch on the cylinder end, but cylinder clevis. Then here on the back, this is a universal mount type pneumatic cylinder. So it has this threaded extension here with a 12 millimeter hole through it. And I just cut a couple of pieces of steel and welded them to an M12 coupler nut. Hopefully that shows my horrible welds. But that and a piece of all thread and another ball socket there gives me, you know, ball sockets on both ends, but it also gives me adjustability. The idea being this ram smacks into its stop before the press runs out of travel, both directions. So right there, the ram is running out of stroke. It's not slamming the press against its mechanical limits, and the same thing when it strikes back. So with, you know, fairly light duty press, I think that was key. And then this is a cheap off Amazon MAL 40 by 250 linear actuator, air cylinder. And kind of what I found when I adjusted this to the stroke I thought I wanted, and I figured the amount of pullback force that this would need, my thrust is above the pivot point going one way, and at the other way, the pullback is still slightly above the pivot point. I can't have this cam back past straight, or it's going to run into issues. But I found that the cylinder has quite a bit of gravity to it, and I did end up lengthening this way, loosening this, and going down a little bit to get the stroke right and the cylinder to run. And then moving on down here, of course, you've got, air pressure here extends the cylinder, and air pressure this way pushes it back. And as it goes one way, air has to escape from the other side and vice versa. So then on this side, you've got just a very basic pressure regulator, water separator filter. And the air is going into a 5-way, 2-position air solenoid. So in a nutshell, when this magnetic coil that operates this valve, you've got pressure coming here in the middle. When this is not activated, air pressure is going out this line, which is the retract line. This line that's the pressure line goes to the exhaust. And these exhaust mufflers are flow control valves. They have little needle valves and little lock nuts, and that lets you keep the cylinder from just slamming one way or the other. It restricts the air as it comes out the side that's venting air, as a way to keep the velocity down and keep the thing from pounding itself apart or cycling faster than the lead press can stand. And then for control, I elected to go 12 volt, so that's a little off Amazon, like a 2 amp, I think, 12 volt power supply. You could have went line voltage for control, 110 volts, whatever, but then you'd want some sort of a fuse or, overcurrent protection. And also you'd have, a shock hazard too. I think if I did it again, I would go 24 volts, just because a lot more industrial controllers and solenoids are available in that. So that wire comes up here. This is just, I think 16 gauge direct burial, like sprinkler system wire, because that's what I had available. A lot of this is just kind of stuff laying around. I have a tendency to reuse. So then this is an Autonix timer. This is an ATS 11W13. The 11 means that it takes an 11 pin, ocular, normal relay socket. ATS is a mechanical timer series. 1 designates that it's a 12 volt coil. So like 2, I believe, is 24 volt, and 3 would be 110 AC. As far as selecting one of these timers, and the 3 indicates it has a 3-second range on the dials. You can change the scale up, if you needed to, but I knew I'd be probably running more than a second per stroke one direction, or I might. So that's why I went with this particular unit. And then it's set at mode F1. And what that does is, as soon as the 2 contacts in the coil, actually I think there's a wiring diagram there, right there. So like any other industrial controller, pins 2 and 11 are the coil. And in mode F1, as soon as the coil is energized, it starts in the de-energized timer, and once that runs out, it comes to the powered on timer. Actually, I'll just kick that on with no air. You'll be able to see what I mean. So it starts with off, and then it goes to on, if that makes sense. And then if I want, more on time, I can dial that up or down or whatever. So kind of my goal was to control the amount of thrust with air pressure to be just enough to knock out military crimp primer reliably, and not more than that, because I don't want this cylinder's running at maybe 25, 26 pounds and has more than enough thrust to do that. I really didn't want to run it, if you ran this thing at 80 pounds and something jammed, I'm sure it could just bend that press into a pretzel. So I want, control the thrust here. Then I'd use, this has a manual actuator, so you can hit it and extend the cylinder and release and have it contract, and I'll kind of dial these down to where it doesn't seem like it's about to hammer itself apart. And then starting it out, I'll run these timers up pretty good, and you'd see it, extend and sit there, and you'd keep backing down the extend time until it just barely pauses. Retract, same thing, only I'd get it dialed down to where it starts again as soon as it retracts. The difference being, if you get a particularly sticky primer, it might take it the ram will lose a little velocity, and it might take it slightly longer to reach the end of its stroke and knock a primer out. So, that's how that works. It actually runs okay, but I think there's a few things I could have improved. If a person ran limit switches or reed switches on a magnetic piston on this air cylinder, you'd have feedback. So, if you had a relay that tripped and sent this to extend, and it continued to extend until the piston got all the way out, to trip it to retract, and vice versa would stay on retract until the piston got in the back. If you had a case bobble, and the die hit it or whatever, the press wouldn't continue to try to cycle back and forth every second. Basically, it would turn you'd have a single crash, and it would just sit there pushing against that case until you shut it off and cleared it. Whereas right now it would, crunch into that case and pull back up and grab another case and try to push it in there and whatnot until somebody stopped it. And, you'd end up with a dinged case, and then it would spit other cases out. And, again, part of that is the quality of the stuff I'm feeding through it. I got the stuff cheap, and that one's packed full of that media, that I culled out. And then the other neat thing about this batch of brass, that's not 9mm, that's 38 super. So I, supposedly sorted brass wasn't so sorted, and you get something like that and it causes a malfunction. So anyway, things I think I did right were making the cylinder hit its stops before the press did. I think that Lee Deprime kit that I've got coming will probably work super well with this. The Dillon feeding it works super well. Things I could have done different. I went big on the press, figuring you can always turn the pressure down. But the weight of this ram has quite a bit of inertia and also some gravity to it, as it's stroking, it's heading down on the end of the stroke. And its inertia, I think, contribute to its slamming. Also, I think it's using more air than it needs to at that size. And then lastly, this has no cushioning. It hits solid metal on both ends of the stroke. So I think they make air cylinders with like a rubber bushing built in so that it hits a cushion on either end. Or they make ones with adjustable air cushion where you've got a little needle valve and kind of a little sub piston on either side of the piston hits a little sub cylinder on the end caps and decelerates the ram for about the last 15 seconds. Those can be had in, needle valve adjustable, or ones that have kind of a velocity sensitive setup. So they basically will decelerate that last, say, 15, 17 millimeters of the stroke before it hits the stop, so that you don't have such a bang and the thing trying to hammer itself apart. And I think that would have been, I think that'll work a lot better, like a 32 size cylinder with endpoint dampening. And then I think I'll be able to open up these bleed valves and have it run faster. Part of what I think I end up having with this thing banging is air is springy, and when this comes down and hits a point of resistance, it'll decelerate the ram. And then when it breaks through that piece of resistance, like it does if it hits a military primer, you're going to have the ram accelerate. And sort of the nature of decapping, where it hits that resistance is very close to the end stop of the cylinder. So you end up with kind of some slamming at the end of the stroke, regardless. So the other thing that I'm not too keen about, with everything powered off, if I had air pressure on this right now, it would be forcing the ram back. And, if something malfunctions, you hit the switch, if it's jammed up cases here by the shell plate, it's going to, retract that arm and maybe shove another case and, pieces fly everywhere, whatever. I would really rather like to have a 5-way double solenoid valve, 3-position. So you can have these with a magnet coil on either side. Some of them are 2-position, so if you energize this coil, it activates air one way. You could energize this momentarily and it would stay latched in that position. Then when you energize momentarily the other coil, it would switch. Or a 3-position valve, you'd have, as long as this is energized constantly, it pressurizes one and releases to the exhaust the other, and then vice versa when you energize the other one. And then you've got a center position where when both solenoids are off, there's kind of a 3rd position, and those can be had with everything blocked. So both of these would be blocked, and so would the incoming air. And you can have them to where the pressure, both outgoing lines are pressurized. I don't want either of those. If this machine was coming down and it hit a case and you shut it off, well, then there's still air pressure trying to push it forward. So if you were to manage to wiggle that pin out, that end of the cylinder still has pressure in it. It could pop you in the face, or you try to, without unhooking the air, if you try to get a case out from under it, you could end up getting your hand smashed in it. So kind of the 3rd option is when both solenoids are de-energized, that both lines to the cylinder are open to exhaust. They call it an open center or an exhaust center 3-position valve. So with this, you've got a magnetic coil and then a couple sets of points where you've got a common, a normally opened, and a normally closed switch, like any other relay, except this happens to have a timer for how long it's activated and how long it's deactivated. So basically, I've got, power coming up here, the positive going through this switch, going to the positive side of the magnetic coil of this. Then I've got a little jumper running to the common of one of these, one of the sets of contacts for positive on that common. And then the normally open side of that contact, I've got a wire running over to the positive side of this solenoid. And then negative is just run up here to the negative side of the coil, and a jumper is run to the negative side of the solenoid. So I could very easily run the normally closed side of that same relay to the other side of a 3-position solenoid, and it would run just like it runs now, except that when you flip the switch, it's not going to slam itself back. The other thing is, when I do shut it off, I time it so the thing is on its backstroke when I shut it off. Otherwise, if it's coming partly forward and you shut it off, it's immediately going to come back, and it may try to pull it'll leave a case partway on the slide or whatever. You can induce a malfunction when you don't let it complete its cycle. So I think that would be a worthwhile upgrade. And like I said, the real way to do it would be proximity switches with a magnetic piston in the ram. You could use that same 3-position double solenoid 5-way valve and 2 hold open relays, and that way if something stopped the ram from running its full stroke one way or the other, it won't reverse until it hits that position switch. One of the reasons I chose to run a timer is I also would like to run my bullet lubricator on the same system. And I've found, so basically this will push a powder coated bullet through a die and size it. And then at the end of the stroke there, that arm hits this plunger that hits that lever and it injects lubricant. So you end up with bullet lube pressed into, the lube groove of your cast bullet. And I've found when you've got like a bigger bullet with multiple lube grooves like that, that you're either going to have to press down on the ram harder than I'd really like to, or if you press gently and just pause for just a split second, then you get full lube coverage. So I thought running a timer would allow me to have a little bit of dwell time on the forward stroke when I run that. But there's no reason you couldn't use limit switches and then put a timer between the limit switch on the full extend and your relay. So you could basically, this would become a control for how long it dwells on the downstroke and nothing else. So anyway, then the rest of this is just a piece of plywood I had laying around and some vinyl from a bathroom project. And since I've got that Lee press and a single stage and this, I didn't really want to take up room here. It's, a place to set a scale. So to set up the control panel here, I had some angle iron and a piece of steel, and I cut that at like a 30-degree slope and welded that on there, as you can see. And God, I can't cut freehand for nothing, but I took a plasma cutter and cut a couple holes here so I could just use a die that I'm not using and attach this to my rock chucker. And of course, however you set it up, it's going to be up to you, but I wanted some distance from the machine. I thought about mounting it on the wall there, but if the machine's malfunctioning, I wouldn't necessarily want to reach past it to be able to shut it off. So that's kind of what I got going there. And then, as you can see, I'm kind of looking at upgrading it. So this is actually a nice Festo cylinder. It's a 32 by 250 stroke, so smaller bore. I'd be ending up running it at higher pressure. The PPV indicates that, as you can see there, that little screw is the needle valve for cushioning on both ends. And the A, I believe, indicates that it has a magnetic piston, so I can run proximity control on this if I wish. And then the other thing that I've got here is a nice 4A 12-volt double solenoid like I was talking about. As you can see, or maybe you can't because this won't focus that close. Anyway, this one in the center position is open to exhaust. So I think I'll try this cylinder and this solenoid just with the timer the way it is set up now and see if I'm happy with that. And if not, then I'll use proximity switches and relays. And I think I actually, I would just use the typical 11-pin ice cube relays that I've got laying around, and that would make things a little more complicated wiring wise. So I've got a negative and positive bus, just to not doing a ladder diagram or anything, just doing it in my head. That just makes it easier. And I do have some proximity switches for another project, but I might try them on that. So anyway, that's that. I hope that's helpful for somebody. And obviously I'm kind of an experimenter that's not don't really know what I'm doing with these cylinders, so if you have any suggestions of something I could be doing better, let me know. Otherwise, if this is helpful to somebody, I hope it's useful. I am about to run out of video here, but here's the same setup. Welded a M12 coupler nut so I could use the same hardware, this time with steel pieces drilled for 10mm bolts to make the pivot mount of this 32 diameter cylinder, and dinked around with it, got it to fit in the same mount, running about similar pressure. But it runs much faster, and you can tell it uses less air. The air compressor will actually cycle off at this speed. So I'm pretty happy with that. It's probably running 1.4 seconds per cycle, so that's processing brass fairly quickly and fairly reliably too. I can't wait to put the Lee Depriming kit on this and see how that affects reliability. Anywho, that should cook through brass fairly quickly. I still will upgrade the solenoid valve on it, but I'm pretty happy with that. It definitely allows a lot faster cycle speed without as much hammering, so I think that's a win. And I'm only at, when it's running, it's closer to 24 pounds on that regulator, so I'm still not using a great deal of force with that 32 cylinder. A little more tuning. Keeps jamming that tube sometimes. I may slow it down a little bit because it does make a lot of racket at that speed. But I don't think it's going to blow the press apart. You'll probably run through that coffee can of kicks already. You see there's potential for more speed. There was one that didn't speed right. And that's out of cases. That kicks butt. I'm pretty happy with how that turned out. Playing around with it. I think I found the plaid here.